is Jesus Ponce, and this is my presentation on engine blocks. So to begin with, why engine blocks? It's always been one of my passions. Ever since I was little, I've always loved vehicles. This is one of my dream cars. It's a GTR 35. It's a Nissan. Um, Growing up, I didn't really have anyone to teach me about vehicles. So when I went into high school, that's when my interest started increasing a lot. We got to rebuild engines and diagnose problems and stuff. It was pretty cool. My goal is to build a vehicle from scrap. I want to be able to design the frame myself and build it, and even the body panels, even to the engine and stuff like that. Um, it's one of my goals. I want to be able to improve the automotive industry. What I mean by that is I've been introduced to a lot of different concepts that were just concepts, and they're not even a thing. But they're interesting concepts, because if you think about it right now, the efficiency of an engine is only about 20%. All the other all the rest of the energy that is produced from the chemical reaction is actually lost due to thermal energy and the exhaust gas expansions and friction and all that. So I want to be able to improve that. And vehicles are a big part of everyone's life. I mean, we all use them. We need them to get around. So to begin with, what are the fundamentals of an engine? So you have 4 different strokes in a cycle. First one is intake. That's when the air and the fuel mixture is introduced into the cylinder. The piston is slowly moving down at that point. Compression is when the piston is moving back up, pushing the intake mixture and compressing it. The power is when that mixture is already compressed and it's ignited. It pushes the piston down, causing the power, giving you power, the engine power. And the exhaust is when the piston is moving back up to push the exhaust out. The kind of reaction that happens is it's a chemical reaction. It's the combustion happening from the fuel burning, and it turns into mechanical energy by pushing the piston down. The weight of four elephants on each piston, that's a statistic from an F1 car. They're obviously different because they're constantly operating at high RPMs, but it's not far off from a modern engine. They do see a lot of stress, and even the exhaust gases reach up to 2600 degrees Celsius. These are the readings for typical engine blocks. Some aluminum engine block would be 16,000 psi. Cast iron can withstand up to 24,000 psi, and billet aluminum, which is a racing engine, 70,000 psi. Those are pretty high numbers. Billet blocks are usually used to get up to like 10,000 horsepower. So it's pretty crazy. So what's the structure like? Well, it obviously varies between which material you're using, but a desired structure would be like the CGI, compacted graphite iron. If you look up here, this is showing you the carbon flakes. So it's just iron being introduced to carbon, small amounts of carbon. It creates a strong bond. It's very, very strong, but it's very brittle. It causes it makes carbon flakes, and it's very sharp, and those sharp points are actually brittle, high stress points. This over here, what they did is that they added magnesium to it, and it actually made the sharp points more like a blob. The flakes were kind of like a blob. So it it improved that brittleness, so it took away the brittleness, but it um, it also took away the strength. It was not as strong as this one over here. Um, so they kind of met in the middle, and they found this um, makeup, and I mean it's increased strength and it's lightweight, so it's commonly used on performance engines, stuff like that. So what kind of properties does an engine need? Um, so properties would include heat conductive, electricity conductive, sound slash vibration dampening, chemical resistant, corrosion resistant, crack resistant. Crack resistant and heat conductive are kind of play together in a similar role. You want an engine to be able to spread out the heat. A common issue with cast iron blocks was cast iron is pretty bad at spreading the heat. Usually the heat will stay concentrated in one area and it'll increase and cause cracks and stuff like that, which is really bad. It would cause your engine to stop working properly. And electricity conductive, obviously the newer the engine is, the more electronics it has on it, and the more need for it. Every electronic, they all need a ground, and quite a bit of them actually ground to the engine block itself. This right here is a spark plug, and the only way for it to work is to be grounded to the engine itself. It's responsible for igniting your fuel and air mixture, giving you that power stroke. Um, Sound slash vibration dampening. Um, I mean, you can see that with comparing an older vehicle with a newer one. The newer one's going to be a lot quieter. Um, Chemical resistant and corrosion resistant. That's just relating to all the different chemicals that you put in your vehicle, such as coolant, oil, power steering fluid, transmission fluid, etc. I mean, obviously you don't want corrosion happening in your engine block. It just slowly erode your engine block and cause more holes, and it's not something you want. That over there is just a different kind of configuration than what a normal one would be. So versus that picture in the other slide, this is called a rotary engine. Um, they like to call it a Dorito because it kind of looks like a Dorito in the middle. But this is where your intake, your air and your fuel would go in, and then it'd compress it into a smaller. It would the Dorito, if you can call it, would turn, and it'd compress it, and then it'd be ignited and cause the Dorito to keep spinning. It's actually called the rotor, and it's not a common engine because they had common issues with blown head gasket and stuff, but otherwise pretty good engines. Yeah, thank you.